Hello everyone, my name is Prerna Suryanshi. Today I will be talking about very important machine learning concept, support vector machine, hyperplanes and margin. Now, why is this topic important in the context of deep learning and AI? Support vector machine are one of the most powerful algorithm for classification. They work by finding the best decision boundary called a hyperplane that separates data into the classes. Think of it like drawing a line in the sand that divided two groups of the seashells. One side has the small shells and the other side has the larger shells. The line you draw is the hyperplane, and the goal is to make sure the line is far away from the nearest shell as possible. That distance is called the margin. The idea of maximizing the margin makes SVM more robust and reducing the overfitting, which is why they are still relevant even when deep learning method exists. So, what exactly hyperplane and margins? A hyperplane is a simply decision boundary. In 2D, it's a line. In 3D, it's a plane. And in a higher dimensional, it's called the hyperplane. The margin is the distance between hyperplane and the closest data points from each classes. The closest point are known as the support vector, and they are key to defining the hyperplane. Mathematically, hyperplane can be written as the wx plus b equal to 0, where w is the support, w is the weight vector, and x is the input, b is the bias. For example, imagine classifying email into spam and not spam. The borderline emails, those are not clearly spam and or not spam, are the support vectors that determine where the separating lines should be drawn. Now let's see how SVM works. First, we input training data with labels. Then SVM finds a hyperplane that separates two classes. The algorithm adjusts this hyperplane to maximize the margin between support vectors. For cases where the data is not linearly separable, SVM uses the technique called as the kernel trick. This maps the data into higher dimensional space where it becomes separable. For example, circular data can be separated by projecting it into higher dimensions. Finally, when new data points come in, then they are classified based on side of a hyperplane they fall. In short, SVM focuses on creating the widest possible gap between the categories, ensuring the strong generalization. Of course, SVM are not perfect. They are computationally heavy for very large datasets. Choosing the right kernel functions tricky. They are sensitive to outliers. And while they work for binary classification, handling multiple classes requires extra extensions. Compared to deep learning, SVM does not scale well for massive unstructured data like images and videos. However, for smaller structured data sets, they are still a go-to algorithm. To summarize, support vector machine uses the hyperplane as decision boundaries and margins to improve the classification robustness. They are powerful, versatile, and widely used in a text classification, bioinformatics, and even image recognition. In the future, combining SVM with deep learning could be bring new opportunity for hybrid models. Thank you for watching, and I hope you found this explanation of SVM, hyperplane, and margin helpful.